Greetings to all of you. In today's session, we are going to discuss about the chemistry, which is related with the international entrance examination or any competitive exam you are preparing for in the national level of India. If you are preparing for IIT and NIT through JEE Advanced and JEE Mains Examination, NEET for medicinal entrance examination, Telangana and Andhra Pradesh, engineering entrance exam, agricultural entrance examination through the EAMCET. In addition to all these, if you are aspiring for any of government jobs through the competitive examinations, for all these, the kind of session, whatever prepared here is very much helpful. Content which collected over here is retrieved from the all previous year question papers, and extended explanation is provided over here. I'll assure that definitely the kind of session will be helpful for your the dream career or else a dream kind of educational strategy. Let's enter into our today's concept. Question number 1, it is related with the IUPAC nomenclature. So here is the organic compound, long chain carbon chain was given, whose IUPAC name should be assigned over here. International Union of Pure and Applied Chemistry assigned certain guidelines in order to name the given compounds. According to this, here 5 options are provided. Among all, the correct answer will be 2, 4, 5. Trimethyl heptane is the correct answer. In order to answer this one, we have to go for what are the possibilities we have. Here, either you can start the numbering from left hand side or right hand side. So if you are starting from left hand side, for example, from this methyl, 1, 2, 3, 4, 5, 6 carbon chain it will be. If you are going to start numbering from right hand side, 1, 2, 3, 4, 5, 6 carbon chain, and if you have another possibility, if you go for another possibility, 1, 2, 3, 4, 5, 6, 7. 7 carbon chain will become the parent chain because longest chain will become the greater priority over shorter one. That's the reason why either left or right you are getting 6 carbons. If you go with this kind of counting of numbers, so that we will get 7 number of carbons. After collecting numbering of the carbon atoms, we have to go for what will be the position of the side chain substituents over here, right? So if you see this, so if you're going to start numbering from this end, you are not able to find the substituents over here, only you can find a third carbon. But if you start numbering from right hand side in this manner, on second carbon itself, you can find the side chain. That's the reason why it will be the shortest. With respect to this starting carbon, even on the second carbon only you can find methyl. Hence, we have to start numbering from right to left only. Right? This is the way. This is the correct way of numbering as per the IUPAC nomenclature. 1, 2, 3, 4, 5, 6, 7. So this is the parent chain. And over here, second carbon is assigned with the methyl. Fourth is also having methyl. Fifth carbon is also having methyl. All are methyl only so that we can clump up in a single line like 2, 4, 5 trimethyl. That will be the 3 methyl substituents over here. After getting this one, you can go for the main chain, right? So for that, heptane being 7 carbon and all are saturated with the single bonds only, we can say heptane is the last name for the given compound. This is the way we can answer, and the final name of the compound is 2, 4, 5 trimethyl heptane. This will be the entire name, complete name for as per the IUPAC nomenclature for given compound. Let's move on to question number 2. In chemistry, there is a term called smelting. What is meant by smelting? Smelting is the term related with metallurgical process. Smelting, roasting, calcination, all these are the part of what? Metal extraction from ores and the minerals. So among all, the smelting is one of the method where we are going to apply in order to extract the metal. Let's see what is meant by smelting process. Smelting is the metallurgical process used to extract the metal from its ore. So ore is nothing but the combination of so many kind of impurities in addition to the metal. And if you are going for a sequential treatment method, sequential refinery method, so that entire impurities got discarded and pure metal is finally extracted, that entire process is said to be metallurgy. right? So here, in case of smelting, you are going for high temperature. You are applying high temperature, being we are operating with metals. Most of the metallurgical extractions will be accompanied by high temperature conditions only. And here, smelting, where ore is treated with the high temperature in the presence of reducing agent. Here, either you can use carbon or carbon monoxide as the reducing agent in order to convert metal oxide into metal form. So the ore or any kind of mineral what you are taking initially is the kind of oxide. For example, iron. Iron may be taken in the hematite or magnetite. All are oxides of metal only, so that you can apply this melting process for the extraction of iron from its oxide form. So high temperature treated with the reducing agent and oxide got converted into a metal. This is the process called a reduction, because reducing agent is added over here. During smelting, metal oxide is typically combined with the flux. Flux may be a limestone or silica. The use of flux is impurities of the slag can be removed. Whatever contaminants present in addition to the given metal, so that impurities can be discarded by the addition of this flux. Here it is limestone or silica can be added. The flux reacts with the impurities to form liquid slag and floats on the molten metal, allowing easily separated. If it is floating, you can easily separate that kind of slag, whichever floating. So a pure metal can be extracted by this process. Let's see what is the process of smelting. So in the smelting process, if you observe at the top, you can find 250, 700, 850 and 15. So the temperature gradually increases as we are descending down, right? So here, this is a kind of device called the blast furnace. In this blast furnace, we have to introduce iron ore. So that might be a oxide ore of iron can be taken. Coke is taken as a fuel over here. Limestone is the kind of slag which is important. Limestone slag is important to remove the impurities in the form of slag, right? So that is floating matter. That floating matter will be deposited at the topmost layer, and the molten iron metal of pure form can be collected at the bottom, right? During the addition of this compound mineral or ore into this blast furnace, so we have to mix it with the reducing agent like carbon monoxide, or carbon can be added over here. So initially it is the form of iron oxide. So after the reaction with reducing agent, iron is turned into iron Fe by removing oxygen form. Either calcium carbonate or silica used as what? Calcium carbonate or silica used as a flux in order to make this calcium carbonate into calcium oxide, right? So whenever calcium oxide got generated, that calcium oxide can bind with the silica and formation of slag will be there. That is a kind of impurity present that is removed from another end. So this is the way we will go for. And finally, here is the oxide of metal is converted into a reduced form of pure metal. So this is a process called smelting. Smelting is a common thing applied for the metal oxides to convert into metal form. Let's move on to question number 3. In the question number 3, this is a kind of nuclear chemistry where you can find the nuclear reaction and what is the element X in this nuclear reaction. Sodium atomic number 11 and resided with the atomic mass 22. There is a compound unknown called X will be generated. In addition, electron and voltage will be evolved. During this reaction, what is meant by X to be depicted? So if you see this, this is called beta plus emission. Positron emission will be there. Whenever positron got emitted, here atomic number 11 is reduced to atomic number 10, and a positron will not have any mass. That's the reason why atomic mass will not be changed. 22 remains as 22 only, but atomic number got reduced by 1 unit. So 11 is converted into 10. Atomic number 10 is given by the noble gas neon. That's why you have to go for the option number 3. Let's see how can we explain this one. Sodium 22 is a man-made isotope. It is the isotopic form and half-life is only 2.6 years. Short half-life is accorded for the sodium 22 and it will participate in a beta plus decay called as a positron emission. Whenever positron got emitted, it is turned into neon 22, right? So beta plus decay when observed for the sodium 22, it is converted into neon 22. Atomic mass remains the same, but atomic number 11 turned into 10. So sodium converted into neon by positron emission. This is a way we can clearly assume. So here correct answer will be option number 3. For question number 3, option number 3 is the correct answer. Let's move on to question number 4. The dimensions of mole, liter, temperature inverse to, atmosphere inverse to belongs to. So these are the units provided and what will be the term belongs to this kind of units. So for that purpose, let's go with one by one and we will predict which is mapping with this one. Magnetic flux is measured in the terms of Weber. Weber is the unit which is given by the scientist, German scientist Weber, and it is denoted with a WB. Magnetic flux units are Weber. And the second term provided self-inductance. Self-inductance is the measure of coefficient of self-induction. How the induction is possible. There are so many kind of electronic devices made up of self-induction. Self-induction stoves will be there, electronic gadgets will be there. So here self-inductance can be measured in the units called henries. So this is also not suitable. And the third, magnetic permeability. Magnetic permeability is measured in mole, liter, temperature inverse to A inverse to. This is the way exactly mapping with the given dimension, so that for question number 4, option number 3 is the correct answer. Let's go with the last one also, that is electric permittivity. In this electric permittivity, SI units are provided Faraday per meter. Faraday per meter are the units for electric permittivity. So by this, we can clearly assume that option number 3 is the suitable answer for question number 4. Let's move on to question number 5. The ratio of potential energy and total energy of electron in a Bohr orbit of hydrogen-like atom, right? Here, potential energy and total energy, that ratio we have to depict. The ratio will be 2. Let's see how it is possible. The correct option is B, that is 2:1 is the correct answer. Potential energy is given by the equation minus Ke square by Rn, and the total energy is given by minus Ke square by 2Rn. Here, R denotes what radius, N denotes what nth orbit, in which orbit electrons are revolving, right? So if you go with this one, K is the proportionality constant over here. And if you go for the ratio of these two, potential energy by total energy is equal to, both the terms got taken over here and both are exactly similar, so that we can compensate, we can cancel out. Being total energy is the denominator value. In this total energy, minus Ke square by 2Rn is denominator to denominator, so that it will come to numerator. Hence, remaining terms entirely compensated, potential energy by total energy is given as 2. So if you take the ratio exactly, potential energy is to total energy is equal to 2:1. This is the way we can answer the question. For question number 5, right answer will be option number 2. So whatever questions we discussed, third and fourth are NEET 2023 questions. These two belongs to. And question number 5 and question number 6 are belongs to EAMCET entrance examination questions. Let's see the last question of the session, that is question number 6. Both the position and exact velocity of the electron in an atom cannot be determined simultaneously and accurately. This is known as, right? Here, being electron is the tiniest particle, subatomic particle, we can say. If you find exact position and its velocity become infinity. If velocity is exactly determined, so position of electron will become infinity, so that it is impossible to measure position and velocity of the electron at the same instant. This is the phenomenon provided by the Heisenberg uncertainty principle. Heisenberg is the scientist who depicted we can't find position and velocity of the electron at the same instance. If position is 100% known to you, velocity will become infinity. We can't predict. If velocity is known, position will become infinity, right? This is the way the relation is provided by the scientist called Heisenberg. This is called Heisenberg uncertainty principle, and it is given by the mathematical equation delta chi, delta rho is greater than is equal to h cut by 2. Here, the uncertainty principle states that we cannot know both the position and the speed of the particle, such a photon or electron. Photon is the light particle, electron is the tiniest subatomic particle in the atom, with the perfect accuracy. So this kind of equation is applicable to photon as well as electron, light and electron as well, right? So this is the way we can say position and velocity can't be determined simultaneously. So by this, we completed the entire session. Hope this will be helpful for your further preparation. If you are aspiring for any kind of prestigious entrance examination or any government job or any competitive examination, so this kind of session will be very much helpful for you. Hence, I'm requesting you to kindly like the channel, comment which part is most important for you, most inspiring you towards the preparation, and share with the people who ever actually preparing for the examinations, and subscribe the channel in order to receive more such kind of updates over here. And thank you very much, all of you, for your patient listening. Thank you, one and all.